So good morning, all of you. So today's topic is multi-cavity klystron. So this multi-cavity klystron is the extension of your two-cavity klystron. So in the cavity klystron series, this is what the multi-cavity klystron. So in the two-cavity klystron, you will have only two cavity. This is what the buncher cavity and the catcher cavity. So here I have kept the another cavity. This is what the representation of multi-cavity. So this is what three cavity klystron amplifier. So as you know, the amplification process that is used for the RF or the microwave signal amplification. So this input signal is given here. This is what your RF input. So RF input is given, and this is what your RF output. So RF input and RF output is shown in the diagram, and here the amplification processes takes place. The main principle is the velocity modulation. It is same as the two cavity klystron. Velocity modulation takes place here, and this velocity modulation, it is for the two cavity, same as the two cavity klystron. Okay. Now this klystron amplifies power output, frequency. uh, why we require the main thing is why we require the multi-cavity klystron. Why but two cavity klystron is sufficient for the power, the amplification. But what are the advantages, you can say, over the two cavity klystron? So it has the advantages in terms of the amplification. The amplification factor is better, it's good, better as compared to the two cavity klystron. The power output, whatever your output power, so power output is high as compared to the two cavity klystron. The frequency bandwidth, whatever the bandwidth we do, whatever the bandwidth we get from the two cavity klystron. Two cavity klystron is having only buncher cavity and the catcher cavity. So in this multi cavity klystron, whatever the frequency, the bandwidth is improved. Then um, the efficiency, as in the RF or the microwave signal, the efficiency is low for the most of the devices. So here it has the better efficiency. The efficiency improvement is there as compared to your two cavity klystron. Okay, so here the this is what the multiple cavity klystron. The input and the output cavity of the klystron are the basic. This is called the input cavity. We can say this as the buncher cavity also, and this is catcher cavity, is also known as the output cavity. Input cavity is this, in the buncher cavity, and output cavity is this. That is what the catcher cavity. Now, this additional cavity, what is the use of this additional cavity? So this additional cavity is used for the velocity modulation of the electron beam, and to provide the increased power at the output. So this cavity, the intermediate cavity, it provide the what the velocity modulation, and this is what the electron beam that increase the what the output power, whatever the output power is increased. So uh, all intermediate cavities, whatever these intermediate cavities, may be one or multiple. So all these intermediate cavities in the multi-cavity klystron operate in the same manner what we have operation in the two cavity klystron. So I'll go in detail that how it is working. Now in this buncher cavity, what will happen? So we are starting from this. That is what the electrons are generated. Electron beams are generated. This is what your electron beam. It travels in this the transverse mode. Okay. Sorry. The electron beam, they travel from here cathode to this collector. Okay. Now in this whatever the multi-cavity klystron, this is what heater, the electrons are generated. Okay, so these electrons are generated, it is given to this anode. So this anode is what you can say, the anode focus the electron. Okay, anode focus the electron and it passes through the other cavity. Okay, now what happened here, as you can say, the electrons came, so they are with their natural velocity, and here the bunching action takes place, and this is for the velocity modulation. So this bunching is done in this cavity as well as in this cavity. So what is this bunching action? So these electrons form a bunch. Whatever the process here is the velocity modulation. Means the electron, those they came, uh, they have varied the velocity. Whatever the velocity of the electron is varied. So the electrons, those they came early, they are coming with the normal velocity, but there is the variation in the velocity of the electrons and the bunching action takes place. So how it takes place, that when the electron, the electron, those they are coming from the end, that is the late electron, their velocity is increased, and the velocity at the early electron, means those they are coming in the first batch, their velocity is decreased, and the middle electron having the same velocity. So due to that, they are coming together and forming a bunch. So this bunching processes takes place. So this is what the buncher cavity. And what is this? This is RF input. With a reference to this input, the we know that the RF signal is having positive upcycle and negative upcycle. So whatever the action I just told, that is the bunching action takes place, that is due to the positive upcycle and the negative upcycle of this RF input. So if the positive upcycle, the electron repel, so they go for the higher, faster. The positive upcycle and negative upcycle has the impact on the electron, and accordingly this bunching action takes place. The same action, same thing is happened in this the other cavity, and the whatever the bunching process, velocity modulation takes place here, and then it go to the further. This is what the catcher cavity. So in the catcher cavity, whatever the RF output, so RF output is taken and it is given at the output. Okay, so this is what your the general process, and at the collector, all the electron beams, all the electrons has been collected. Okay, so what is the difference here, unlike your two cavity klystron? So unlike your two cavity klystron, the entire drip tube assembly, what is the drip tube assembly? This is what the entire drip tube assembly. So whatever this tube, so you can say it is the drip tube assembly. So this is what one, two, three, these tubes are there. So entire these, all these tubes are called the drip tube assembly. So the in this drip tube assembly, the three cavity, whatever the three cavities are shown, and the collector. Okay, collector plate of the three cavity klystron are operate at a ground potential. Okay, whatever the potential is here, that is operate at the ground potential. What is the reason for that? So here the reason is the safety reason. For the safety purpose, it is operate at the ground potential. So the electron beam, here is the electron beam, whatever this electron beam. So the electron beam is accelerated towards the drip tube by the large negative pulse applied to the cathode. So the for the cathode, as you say, the large negative pulse is applied to the cathode, and then it is due to this large negative pulse, the electron beams are generated. Okay, so and the another thing is the magnetic force coil are placed around the drip tube to minimize the beam spreading. So around this is only the schematic. So around this, whatever the tubes are there. So here in this direction and in this, the at the top and the bottom. So a magnetic uh, force coil. So this magnetic force coil are placed. Okay, to minimize, what is the purpose of this magnetic force coil which are placed here and here? To minimize the whatever the impact, whatever the electrons beam, that should be focused, to avoid the spreading of the electron beam. They should be focused. As they are focused, the bunching action, it helps in the bunching action. In the high power klystron, the concave shape of the cathode uh, that adds the force on the beam. So it is mainly it is in the high whatever the high power application. If the power of, there are multiple power levels of the klystron based on the requirement and the application. So for the high power klystron, the concave shape of the cathode is used. Okay, so this is what the schematic. Now the electrons are velocity and density modulation, density modulated. So these electrons are the velocity modulated, and they are acts upon by the RF field. As I told that due to this RF field, the velocity modulation takes place. So this is across the input and middle cavity. So this happens at the input and the middle cavity, while the electrons are traveling through the drift space between the cavity. So this bunching action, bunches are formed. Whatever these bunches are shown, so these bunches are formed. As a result, bunch electron deliver energy to the output cavity. Whatever this bunch electron, they deliver energy to the output cavity. Here this is output cavity, which where we can also call this as the catcher cavity. Form is kinetic energy. So how it deliver energy? For whatever the kinetic energy of the electrons are there, this is vacuum tube. Okay, this entire path is vacuum tube. So electrons are traveling here in a vacuum tube. There is no conductor, nothing is there. It is a vacuum tube. So electrons are traveling in a vacuum tube. So they are following the convection current phenomena, whatever the related things are there related to convection current. So that phenomena they are following, not the conduction current. Here the electrons are not flowing through any conductor, they are flowing through the vacuum tube. That's why they are this bunching process and all these things, they are the things you can relate with the convection current. So this the electrons, they deliver energy to this output cavity. So the kinetic energy that was originally absorbed from the cathode pulse. Okay, so this kinetic energy is converted into this whatever the this is catch here. So the Klystron amplifiers has been built with as many as tubes. How many the intermediate tubes we can have? So as many as generally the 5 tubes are there. That is whatever the intermediate tubes are there. So to have the power amplification, generally not more than 5 tubes are used. So multi-cavity means there may be 2, 3, 5. There may be 3, 4, 5, whatever the number of cavities are there. So here generally the as many as the 5 cavities can be used. So this is what purpose, the bunching, to increase the bunching action. And what will happen if you will have the bunching action more? So it will increase the amplifier gain, whatever the amplifier you are having, so amplifier gain. So if you require the high power, then obviously the high amplification factor, then obviously the number of tubes will be more, as maximum as up to 5. The overall efficiency of the tube is also improved to a smaller extent. So the efficiency by the multiple tube, the efficiency is increased, but it is not up to great extent. It is up to the smaller extent. The multi-cavity amplifier tube will produce high gain and a narrow bandwidth. So whatever the multi-cavity klystron, they are producing the high gain. The gain is high. That's why we are using this as the multiple cavity. And but it will have the narrow bandwidth. Whatever the bandwidth will be narrow. In which case narrow bandwidth is there, but some condition is there. You will get narrow bandwidth in condition that all the cavities are tuned to the same frequency. Whatever this cavity, whatever the number of cavities are there, if they are tuned to the same frequency, if all these cavity are tuned to the same frequency, then obviously the bandwidth will be the narrow. And what this is called, this is called as the synchronous tuning. Whatever the tuning of this tube, it is called as the synchronous tuning. And in the synchronous tuning, what is the advantage? Obviously you will have the high gain, but the bandwidth will be narrow. Okay, but the another possibility is also there. What is that? When each of the cavity are tuned to the slightly different frequencies. Suppose this is at some lower frequency, it is little bit higher than this, and if there is another, then whatever the multiple cavities are there, if they are tuned with the little bit different frequencies, then what happened? Obviously bandwidth will improve. Okay, so if multiple cavities, if they are tuned with the different frequency little bit near to each other, so what, they are forming a large band, so the bandwidth will improve. But there's a bandwidth increase, but it affects what? It affects the gain. So whatever the gain of the amplifier, it get reduced. So whatever this different bandwidth, slightly different bandwidth tuning is called the stagger tuning. Okay, so it is called the stagger tuning. So it based on your application, whether you want the larger bandwidth or whether you want the larger gain. So for the larger gain, you can have the synchronous tuning of all the tube. So in the synchronous tuning, you will get the large gain, but the bandwidth will be narrow. And in the staggered tuning, what is staggered tuning? Every tube is tuned at a little bit different frequency, so obviously it impact the improvement in the bandwidth. So bandwidth will be improved, and you will get the staggered tuning. So it increases the bandwidth, but it reduces the gain. So the fundamental principle, we know that the gain and bandwidth product, it remain constant. So this is the trade-off, that when you will increase the gain, it impacts the bandwidth will reduce. And if you increase the bandwidth, so it impacts the gain. Okay, so you can say the gain bandwidth product remain constant. This is what you can say the basic principle. So this is what your multi-cavity klystron. So as much as you can have the multiple, that is the 5 cavities can be increased. The main purpose is to improve the amplification factor, power output, frequency, the whatever the frequency bandwidth, and the efficiency. So that's why we are using this multiple cavity, whatever the multiple cavity klystron amplifier. So this is what the operation is the same as the 2 cavity klystron. As maximum as you can have the maximum 5 cavities, and two type of the tunings are possible, that is the synchronous tuning and the staggered tuning. Synchronous tuning give the high gain but comparatively narrow bandwidth, and the staggered tuning, it gives comparatively a large bandwidth. मतलब bandwidth is increased, large bandwidth, but gain will be comparatively lesser. So this is about the multi-cavity klystron. If you will have any question, so let me know. Otherwise, we will stop out here. So this is regarding the multi-cavity klystron. Thank you.